All right, so in this video, we're going to continue where we left off, and we're going to run an ordinary least squares regression of our logged Bitcoin price onto log stock to flow. And the regression specification, is again going to be logged Bitcoin price, BTCT, sub T is going to be equal to, they're going to use ordinary least squares to estimate our coefficients. So we're going to get an estimate for beta 0, an estimate for beta 1 multiplied by the log of stock to flow plus our error. And this is the specification of the regression. We're going to use ordinary least squares in order to estimate our coefficients. Remember, this is going to be used to estimate log Bitcoin price. To actually calculate Bitcoin price, you'd have to do e to the power of log Bitcoin. So that would mean e to the power of this is equal to e to the power of all of this. This would give, of course, natural log, and e would cancel out. This would give you BTC at time t. So the price of Bitcoin would be equal to e to the power of our regression. So beta 0 plus beta 1 times log stock to flow plus our error. Of course, that could also be equal to e to the power of the intercept plus e to the power of all that, and so on. Either one would work. Well, anyway, so now to actually do it in our notebook. So we're going to continue. First, we have to import stats models. Let's import statsmodels.api as SM. And this will let us use everything related specifically to linear regression. And now let's create our regression variable. So we're going to use, we're going to say reg is going to be equal to stats models dot ordinary least squares, OLS, and our endogenous variable is going to be equal to our dependent variable. Then our exogenous is going to be equal to our explanatory. Let's do this a little bit differently. Let's say y is going to be equal to you will use numpy log of our price. Let's say x is going to be equal to numpy log our stock to flow ratio. So now our endogenous is going to be equal to y. And remember, whenever we do this, we fit and we print, there's an error in this. There's a problem. It's still going to run, but it's not going to be what we want. We have just one coefficient, and that's for the slope of the log of stock to flow. We have to have the intercept, and the way stats models works, or at least for ordinary least squares, you have to manually add that column of constants or ones in order to make it work. So we're going to do we're going to say the endogenous is equal to our y variable, which is the natural log of Bitcoin price, and our exogenous is going to be equal to sm statsmodels.add constant x, or the natural log of stock to flow ratio. We have to add the constant, and this is what gives us our intercept. So this is going to be our summary. So our x reg equal to statsmodels.ordinary least squares. Endogenous is going to be our y, which we specified up here. We signed up there, and our exogenous is going to be sm statsmodels.add constant x, which is specified up here, dot fit. So this fits the ordinary least squares, or uses ordinary least squares to fit and find the coefficients. And then we're going to print the regression summary. And this is what prints this out. This is what I want to see in the report. And I want to brief explanation. So if we look at this, we can see that the just judging by this ordinary least squares regression results, it seems like a pretty good model. You can see that it is statistically significant. The t-stats are statistically significant. The coefficients are good there. The f statistic, this is statistically significant. Everything based on this would lead you to believe, if you're just judging by this up here, it will lead you to believe that this is a good model. And then we'll use a reg plot down here. So let's do seaborn.regplot. And in this, our x variable is going to be our, let's just say x. We already specified it. Y is going to be y. Let's run this. So x up here, we already created that. Capital X is the natural log of the stock to flow ratio. And then our y is already the natural log of the price of Bitcoin. So that's already done. I mean, this isn't price, it's natural log price. This isn't stock to flow, it's log, natural log stock to flow. But this is our regression line. It seems like a good fit, just judging by our t-stats, f-stat, and r squared. So this is part 3 and part 4 of the project. Remember, we're trying to fit a model that describes the relationship between log Bitcoin and log stock to flow ratio. In the next video, we're going to go over the Gauss-Markov assumptions, or the classical linear regression assumptions that we talked about back in chapter 8. And we're going to see, or we're going to test this against the assumptions and see whether or not this actually is a good model. So that'll be in the next video. This is it for this one.